Good morning, students. I am Nagamani, JL Chemistry Naidpeta. Today we are going to learn about catalytic properties of the transition elements. We have already known the magnetic properties and then complex compounds formations and multiple oxidation states in our D block elements or the transition elements. Now we are going to learn about the most important characteristic features of D block elements, that is catalytic properties and then interstitial compounds, and next third one is the alloys formation. So first one is catalytic properties and second one it is interstitial compounds, and third one is the alloys. So these are the main important characteristic features of the transition elements. Up to this alloys, the characteristic features of transition elements will be completed. So first we will go to learn about the catalytic properties of the transition elements. First of all, what is a catalyst? We have already known that a catalyst, it is a chemical substance which does not involve in the chemical reaction, which does not involve in the chemical reaction, but it can activate or it can encourage it can speed up the chemical reaction, involved in the chemical reaction, but it can speed up the chemical reaction, so that is the catalyst. It does not involve in the chemical reaction, but it can speed up the chemical reaction. So most of the transition elements, they will involve as a very good catalysts. Almost all the transition elements, they will involve as a, and they will work as a very good catalysts. So why they are used as a very good catalysts? So what is the reason for that catalytic property of the transition elements? Now we will go to learn about and we will discuss the catalytic properties of the transition elements. First of all, the transition metals and their compounds will act as a good catalysts. Transition metals and their compounds those compounds may be oxides or sulfides or any other the compounds. So transition metals and their compounds, they will act as a good catalysts. The reason for this is the reason for this good catalytic property, they will for the multiple oxidation states, due to they will exhibit multiple oxidation states. Due to this multiple oxidation states, they will easily act as a catalyst. And next one is the formation of complexes. So they will give a complexes. These transition metal ions will give a complexes with the reacting molecules. So these two are the main reasons for the catalytic property, very good catalytic property of the transition elements. And next one, best example of the catalyst is the what is the best example? The best example is we have already known, that is vanadium pentoxide. Vanadium pentoxide is a compound. It is a compound of vanadium and then oxygen. So it will act as a good catalyst in the preparation of sulfur trioxide. 2SO2 plus O2 gives rise to 2SO3. In sulfur dioxide gas, it is converted to sulfur trioxide gas in the presence of vanadium pentoxide. This sulfur trioxide gas is used in the preparation of sulfuric acid. It is used in the preparation of the sulfuric acid. So here the vanadium pentoxide, it is the compound which is very good catalyst of transition element. And next we will go to the another example, that is iron is a finely divided iron. Finely divided iron. It is also used as the one more catalyst in the preparation of ammonia. N2 plus 3H2 gives rise to 2NH3. Finely divided iron, it is used as the best catalyst in the preparation of the ammonia. So that is the second best example. And next example is the we know that almost all oils are in the liquid state. When these oils are hydrogenated, that means these oils reacted with hydrogen in the presence of a nickel catalyst, they will become as a fats. They will converted as fats. Those fats are in the solid state. So the hydrogenation of oils can be carried out in the presence of the nickel catalyst. So these are the best example and easiest examples of the catalytic property of the D block elements. How they will act as a catalyst. So the mechanism of the catalytic property. What is the mechanism which is involved in the catalytic property or the catalyzation, which is involved in the catalyzation? Catalyst as a solid surface. We are taking all these metal catalysts. So that is the metal as a fixed surface. This one is the metal surface. When the reactant molecules approaches the metal surface, and reactant molecules approaches to the metal surface. So these reacting molecules, these are called as RM. RM means reacting molecule. There is a chemical bond in between the reacting molecules and the metallic surface. So this chemical bond, either it may be covalent or ionic. It may be a covalent bond or the ionic bond. So there may be a chemical bond in between the reacting molecules and the surface, metal surface. Due to that chemical bonding or chemical attraction, the reactant molecules will form a complex with the metal surface, and then that complex weakens the intermolecular forces of reactant molecule. Intermolecular forces of the reactant molecules. When the intermolecular forces are weakened, those molecules get absorbed only by the metal surface. So that is the main mechanism involved in the catalytic property. And next one is the, for example, if we take the 3D series elements, what are 3D series elements? That is scandium to zinc, scandium, titanium, vanadium, chromium, and so on up to zinc. In 3D series elements, the involvement of the electrons are the 3D and 4s electrons. 3D and 4x electrons are involved in the chemical bonding. So, and next one is when these chemical bonds are forming in between the reactant molecules and metal surface, the reactivation energy of reactant molecules decreases. Activation energy decreases in the reacting molecules. Activation energy decreases. And next one is the bonding between reactant molecules weakens. Bonding between reactant molecules weakens. That means it will be gradually decreases. The force of attraction between the reactant molecules gradually decreases. So, and next one is this effect will increases the concentration of reactants over the metal surface. Increases the concentration of reactants over the metal surface. That means more number of reactant molecules are attracted by the metal surface. And next, fourth one is the transition metal ions can change their oxidation states. They will change their oxidation states. Change the oxidation states. So they become more effective. By this process, they will become a more effective catalyst. More effective catalyst. That is the mechanism which is involved in the catalysis of the transition elements. So, for example, if you take iron 3 ion Fe3 plus catalyzes iodide ion in the presence of persulfide, that is the S2, in the presence of S2O8 2 minus persulfide ion. So iodide ion and persulfide ion is catalyzed by the iron ion Fe3 plus ferric ion. So the equation is like that. 2I minus gives rise to, it is catalyzed by the ferric ion. It is catalyzed by ferrous ion Fe2 plus ion. It will give us S2O8 2 minus persulfide ion. It gives I2 plus SO4 2 minus 2SO4 2 minus. So this reaction can be it can be expressed in two ways. That is the explanation. How we can explain this reaction? First of all, in first step, 2Fe2 plus 2I minus gives rise to 2Fe3 plus I2, and here Fe2 plus ions are converted to Fe3 plus ion. So another step, that is 2Fe2 plus S2O8 2 minus gives rise to 2Fe3 plus 2SO4 2 minus 2SO4 2 minus. So these are the two steps which is involved in this Fe3 plus catalyst in the iodide ion and persulfide ion. So next one is the second one, formation of interstitial compounds. This is the second property, formation of interstitial compounds. In crystal structures in solid state, we have already known the interstitial spaces. What are the interstitial spaces? If you take a small crystal, in that crystal all molecules are in a closely packed arrangement. So the space in between these molecules, space between these molecules it is called as the interstitial space. So these spaces are called as the interstitial spaces. When small atoms like carbon, hydrogen and nitrogen, they are very very small and less atomic radii containing atoms. So these atoms will occupy these interstitial spaces, so those compounds are called as the interstitial compounds. When small atoms like carbon, hydrogen and nitrogen, if they occupy the interstitial spaces of the crystal lattices of transition elements, those compounds are called as the interstitial compounds. So they are usually non-stoichiometric compounds. These are non-stoichiometric compounds. We have already known in the solid state. These are non-stoichiometric compounds. And second one, they are neither covalent nor ionic. That means there is no covalent bond or there is no ionic bond in between the small atoms and the transition element. So neither covalent nor ionic. Example, best examples for the interstitial compounds, that is titanium carbide TiC, manganese nitride Mn4n, and iron hydride Fe3H, and vanadium hydride VH 0.56, and titanium hydride Ti H2.7. So here the 0.56 and 2.7, they are the fractional values. So that means there is no fixed ratio in between these two atoms of the interstitial compounds. So they do not show the fixed oxidation number. The metal does not show any fixed oxidation number or normal oxidation number in these interstitial compounds. That is the main important aspect of the interstitial compounds. They do not expect a normal oxidation states because of their compositions, and their compounds are referred to as the interstitial compounds. Next one is the characteristic properties of interstitial compounds. Characteristic properties of interstitial compounds. What are the main characteristic properties? First one is they have high melting and boiling points. They have the high melting points. So these melting points are as higher than the original metal or pure metal. Original metal or the pure metal. And next, second one is they are hard, very very hard elements. Interstitial compounds are very very hard. Some of the borides means boron containing interstitial compounds. They are called as the borides. Some borides are as hard as the diamond. And next, third one is they retain metallic conductivity. And fourth one is they are chemically inert. So these are the main important characteristic properties of the interstitial compounds. And next one is the alloys. What is an alloy? Alloy, it is a homogeneous solution of two two metals or the two solids is a homogeneous solution of the two solids, that is called as an alloy. So in which atoms of one metal randomly distributed in another metal. So atoms of one metal randomly distributed in the another metal, that is called as the alloy. So why alloys are formed? Easily formed by the transition elements. What is the reason for the alloys formation? The reason is transition elements have the similar atomic radius. They have the similar atomic radius. The difference in the atomic radius of one element to the another element of same series, it is below 13%. The difference in the atomic radius, it is the below 13%. So they have the very smallest variations in atomic radius, so they can easily combine with each other, so they will easily give the alloys. And next one is what are the properties of alloys? Alloys are readily formed by these metals because of the similar atomic radius. They often have the high melting points. These alloys are also having high melting points, and these are also having very hard. And they have high melting point than the pure metals. And next important alloys are industrially important alloys are the first one is ferrous alloys. So these ferrous alloys, they will contain chromium, vanadium, tungsten, molybdenum and manganese. Chromium, vanadium, tungsten, molybdenum and then manganese. They are so used for these are mainly used for the production of a variety of steels. And stainless steels. And next one is the alloys are the alloys of transition elements with non-transition elements or. So alloys, here we discussed the iron alloys, they consist of all transition elements. When another type, that is transition element with non-transition elements. So what are those? Copper and zinc. Copper is the transition element, whereas zinc is the non-transition elements. You have a doubt that zinc is also a 3D series element. Why it is called as a non-transition element? Because zinc has the completely filled orbital 3d10 4s2, so it does not called as a transition element. It is called as only D block element. In 4D series cadmium, and in 5D series we have the mercury. These three are called as the non-transition elements because of the completely filled d orbital, because there is no unpaired electron in these elements, so they are called as the non-transition elements. And copper and zinc, it is called as the brass. And second one is the copper tin. Tin is in the 14th group element. It is in the carbon family. So copper and tin, it is called as the bronze. So these are also having the most industrial importance. importance. So that is about the characteristic properties of the transition elements that we have. Now we have discussed the properties, that is catalytic property, interstitial compounds, and third one is the alloys.